What's the total work done on the particle by the electric field as it moves along this path? From W to X to Z to Y. 0. Okay, just add them up. You good with that? Let's just finish this page and we'll call it a day. Oh, sorry, that's not number 2. This is number 2. Suppose the particle travels from W to Y along the arc shown. Is the work done by the electric field W, Y, traveling a path like that, work done positive, negative, or 0? Zero. It's just like from X to Z that we just did, right? Because the force is always perpendicular to the motion, to the displacement. Okay? And for part 3, instead of taking the arced path, we're going to go from a straight line from W to Y. The work done by the field on the particle is 0 again. If you draw it carefully, you can see it's perfectly symmetric. The field is pushing against it part way and with it part way. It's symmetric. It's going to do the equal and opposite work, the two halves. But there's something special about this field. What do we call that? A conservative force, right? A conservative force, a conservative field. Gravity was our first conservative force we encountered, and we said that because it was a conservative force, we didn't have to, the work done on any path between 2 points was the same. So all we had to do was look at the endpoints. And we defined a potential energy that had to do with the endpoints, right? And we could just look at the change in potential energy. It would tell us the work done moving from those 2 points. We didn't have to calculate it for the given path. And then our next force that we came to that was conservative was the spring force. We came up with a potential energy for the spring force. And we could figure out the work done by the spring moving from one point to the other. Didn't matter the path taken. And now we're seeing the electric force is also a conservative force. It doesn't matter what path we take going from A to B. All we need to do is look at the endpoint. So we will come up with an electric potential energy for our electric force, the same way we did for our spring force and our gravitational force.